I guess we should start. Yes? Okay. On the door. He's closing the door. Good morning. Welcome to Six Man in Montreal. It's not raining today. So we have a tight agenda. We didn't get the usual 2-hour session, so we've tried to allocate the time. We were able to accommodate everyone requesting, but we'll need to manage the times to get through the agenda. Let's see, and I use this.
Yes.
I'm Bob. This is Jen.
This is our new mascot.
Right. So this is the formal IETF Notewell, the new version of it with a QR code. But after a long discussion in the working group chairs session, we believe that the accurate summary of this is that you have agreed to these guidelines when you registered. And I think our main thing is that everyone is expected to behave in a professional manner and expect and extend courtesy and respect to all of our colleagues. And here's a link back to the Notewell.
Yeah, and if you don't know what you agreed on when you registered, please take a more detailed look at the links in the note. Well,
Yes. And this one, actually, you can actually read in the meeting, unlike the other one. And this is our usual instructions on using Meet Echo. Everyone in the room should be using the on-site tool. And you will, of course, need to be in the queue to speak. We can see the queue and we'll call people. So whether you're in the room or remote. So our administrivia, the links. Lu is taking minutes, and here are links to presentations and the tools and the minutes. If anyone else wants to take minutes, you can go to the notes tool and add. It's always fun to do that and watch someone else add text that you didn't add.
yeah, just a reminder, if you are in the room, please open either on-site client or full client and join the Meet Echo using lightweight client maybe. So you can join the queue and you appears in the kind of blue sheets thing as well.
Good. And the ITF SSID is running IPv6 mostly again and seems to be working quite well. Is this still current?
Yeah.
Okay. I mean, the thing about Apple and
Yeah.
good. Okay. Works well for me. Okay. The agenda.
Okay, yeah, so agenda is on the slide. We have a number of working group documents today. Can I get the clicker? So yeah, I'm not going to read it out loud. We have one active individual draft, and we have three, if time allows, category for things which might be of interest for the working group, but have not been actively discussed on the list yet. So document status. We publishing things. We have published 3 RFCs since last meeting. We have 2 documents sitting in misref state because they referring to the SNAC simple draft. The kind of interesting dependency, SNAC router array flag has a SNAC symbol as a normative reference, and 6724, I think, refers to a router array flag. So we all patiently waiting for the SNAC working group to advance the document. We have IPv6 reflection in ISGQ currently, and Slack renum.
Sorry, can I just
Yeah,
go back one? Just with respect to IPv6 reflection, it has a normative reference to 8335 bis, which is in internet area. and it's stuck in working group last call because there hasn't been enough support for 8335 BIS. And so if we want ICMPv6 to proceed, it would be great to have support for that working group last call in Interia.
Oh, yes, thank you very much, Bill. Yeah, a very good point. Yes, if you care about this, yeah, please review, because I have been commenting recently that sometimes working group last calls do not have enough review, and Interia now requires 5 reviewers during the last call for the document to proceed. So, yeah.
Tim?
Hi there. Just, I don't know if Lorenzo's in the room, but there was discussion yesterday about a potential for a 6724 BIS. I don't know whether there was any intent or desire to claw this one back and make a further change, or whether that would be another document.
Yes.
You were in the meeting, I think, Jen, as well.
Yeah.
So maybe you can comment on that.
Yeah, good point, Tim. We have not put anything on the slides, but yeah, I think Lorenzo is coming to the mic to answer, but we've had some offline discussion about that.
Okay, thank you.
Yeah, we thought that, this is sort of discussion over coffee, we thought that we should try to see if we could write some text that made sense. And if we could, then we could see if it was sort of like sufficiently short to sort of think about putting it 6724 BIS, and then potentially saying, okay, let's go to the working group. If we all agree that we'll make only this change, and the ISG is also like knows that we're only making this change, that we could maybe just do a simple, yeah.
I realized we probably need to get the room up to speed. Yesterday at Happy, yes, sorry, we were talking like everyone were here. Apologies. So yesterday at Happy, it was a discussion about what Happy Eyeballs needs to do in various scenarios, like host being dual stack or v6 only host with CLAT, when it gets synthesized address. So basically various corner cases. Do you want to send traffic through CLAT versus using synthesized records and so on? And this is kind of overlapping thing between 6724 and Happy. And Lorenzo suggested that that discussion does not actually really belong to Happy, and Happy could just rely on 6724. So maybe some updates might be needed to 6724 again. So I think, but as we again discussed it yesterday in Happy and today in hallway, we might actually start with describing what we want to achieve and see if any updates are required for 6724. And if they are, by the time we get there, we can see of the status of 6724. And yeah, maybe we can just do another quick revision with, if possible, slightly more lightweight reviews from ISG. I don't know if it's possible, just to look at the updates to the BIS, which was already been approved by ISG for publication. But because yeah, most likely 6724 gonna be sitting in the MISREF for a while. And if we are all productive and working fast, we might get the updated text there before it gets published.
Okay, thanks.
Right. So it sounded like we wanted to prefer native IPv4, then sort of synthesize Net64 over v6, and then CLAT. And I think that can't be done by just destination address sorting. We have to add a rule to say that, CLAT is depreferred over v4. I think we'd have to add a rule sort of somewhat before the precedence rule. It doesn't look like a big change, but yeah. But we would have to sort of sit down and like figure out how to write it.
Yeah, so I guess we probably do not need to discuss implementation details right now. So I took an action item of drafting something which could be discussed here or in Happy and in both. And when we agree on what we're trying to achieve, we can see what exactly we need to write and in which document. Okay, so yeah, again, ICMP reflection, please read the document and comment. Slack renum currently in the last call. The reason it's been sitting in the last call, the chairs would like people who raise some comments to confirm that the most recent revision addresses those comments. I believe it's almost done. I need to check the mailing list, but I think we're like getting there. And as soon as it's done, yeah, we'll be looking for Shepherd probably and advancing the document. Lawrence, are you still intentionally in the queue or shall I remove you? Okay. Okay, now a more interesting topic. So extension header limits draft. That document got 5 discusses during ISG review. Unfortunately, no consensus was reached during the ISG review between area directors and the author. So ISG returned the document to 6 men for further work. The chairs looked at the current state of the discussion and made a conclusion there is no consensus currently on content of this document. So document has been released from the working group and now is an individual internet draft. I seen questions on the mailing list about what we're going to do with the problem. I do not think anyone is saying that we could not work on this problem. So if there are volunteers who would like to work on this, feel free to either take this document or write a new one. But I think the most important thing is not to do the same thing over and over again, expecting different results. So whoever is going to work on this document, we would suggest to look at the ISG discussion to make sure that new document is capable of addressing those points. Elliot.
Yeah, I also, my other personal thought is that it may be that breaking it into several documents might be a better approach. We were successful in doing the hop by hop processing draft, which focused on that issue, trying to set a minimum requirement for hop by hop options. So maybe another way of looking at this is, deal with the host side or deal with the router side and do those in separate documents and not try to put it all together in one. But again, as Jen said, I think a different approach might be better. Elliot?
Thanks, Bob. Elliot Lear, Independent Submissions Editor. As was mentioned on the list, Tom asked me to consider the draft as an independent submission. He also noted that I told him it would be an extremely rough ride, I think were the words I used, if he attempted that. The 5 discusses plus support for those discusses by other ADs don't go away just by stream. Furthermore, the ICE really generally can't make changes to documents. I can't allow for updates to IETF documents without IETF consensus. So this document appears to update RFC 8504. It also may update RFC 8200. So I'm not going to touch it with a 10-foot pole, and I'm going to leave you guys to sort this. I think it does, the issue is a serious issue. I think Tom is a serious person, and he's trying to address a serious problem. And I think the people in this room also are capable of doing that as well. So I'm expecting the work to continue here, but regardless, the ICE is not going to take any action.
Tim Winters. So the thing about this, and I hearing that, it makes a little bit more sense. I think I was one of the people who asked on list why this wasn't a working group document, because I think it's something as a working group we need to work on. But what I'm hearing is that version of the document is what we're not doing, and we're going to work on this in different ways. Is that?
Yep. Yeah.
Okay.
So basically, again, nobody said we shouldn't be working on the problem, right?
Got it. Okay.
Tim?
Hi, yeah, obviously Tim's going to mention it as well when we discuss 8504 BIS in a moment. I think the other thing from the document that Tom produced, I think there's good stuff in there that extends what is in 8504 about protecting a node from excessive hop by hop or options. So I think that text is useful. That would be a useful thing to have as a standalone RFC that 8504 BIS could point at. And also it seems from the discussion on the list that there is some other protections in Linux anyway. I think Tom said there was a limit of 8 options. It won't process any more than 8 options anyway. So that sort of thing from a protection point of view is good without getting to the more controversial how big a header may be. So I think pulling out the protecting the protection from excessive hop by hops is good. And that then sits nicely alongside Bob and Gory's previous RFC about processing hop by hop options.
Thank you. Suresh Krishnan, I was the document shepherd for this document. So I do want to raise like one higher level point. Forgetting about all the discussions like at the technical level, I think one of the issues that kind of derailed this whole thing was that this document was trying to specify here is the minimum thing you should support. And the position that it brought up was like, hey, by setting this minimum thing, you're kind of ossifying this thing. And then it becomes a new maximum, right? Because like if you say, this is the minimum you need to do, everybody's just going to fall down to that, right? I think that's the higher level bit we need to consider before we do anything with it, because I think it's a valid concern from both sides, but I think we as a working group needs to decide, like, which of these takes precedence, because without that, I don't think this kind of document is going to go anywhere. Thank you.
Okay, thank you. So yeah, there is a very active discussion on the list about this document. So again, if people think it's a problem and they're willing not just talk about it, but write something and bring it to the group, it would be great. Thank you. Okay. Yes, our standard reminder. A lot of other protocols do rely on IPv6, and obviously we are getting a lot of agenda requests for drafts related to other groups when some protocol changes might be required on IPv6 side. Our standard policy is that we'd like the draft to be either adopted by another working group, or at least we would like to get an explicit request from other working group chairs stating that working group decided it's a problem worth solving. Because sometimes the draft in question might talking about a problem for which this room might not have an expertise to make a decision, is it actually a real problem worth solving? So yeah, if you go in to send us an agenda request for something which has not been actively discussed on 6-man list and related to other groups, please talk to the chairs. Oh, yes. I don't know if you've been following. Warren Kumari sent email to the list. There is a ICANN proposal, and I believe they're waiting for public comments on the proposal. They would like to reserve a special IPv4 and v6 addresses to be returned in DNS requests for TLDs, which are going to become an official TLD, like whatever string you use in your company, internally in your network, thinking that it's never going to be public and so on. So there is a link to do public comments. I think that there are two parts of the problem, right? How exactly would be solving that problem, and if solution they choose is going to require some special IPv4 addresses to be reserved, that needs to be decided at IETF, right? So feel free to go and say what you think about that in this link, because currently there is no internet draft. It's just a discussion on IETF mailing list, but this needs to be sent to ICANN for them to consider. Jordi.
Yes, if you participated in the plenary, I raised the point. I was assigned as volunteer by Eric. So I am going to have a draft, not just for the IPv6 address, but also for the IPv4 address. Because I don't think, and some other people don't think that 127 is the right one. So probably I think it should be an in area because it's IPv4 and IPv6. Okay.
Yes, that's a very good point here. We discussed that it does look like something interior might want to consider, because it's not just about IPv6. Or maybe, I don't know, interior DNSO, but it does not look like v6 specific thing. Yeah, so thank you. And I think it's the last slide for chair slide. We're actually running out of time, right, I guess? Oh, yeah, okay, so let me go to our first presenter, which I believe... Suresh, okay. Let me... yes... I'm getting your slides up. You want clicker or you want to voice control?
I can do.
Okay, hold on.
I think before she brings up the slide, I can finish my presentation, but we'll see.
Come on.
No, I'm just kidding.
Okay, you should get control.
Yeah, thank you. Thanks. So this draft is like a fairly short draft. If you haven't read it, you can read it now by the time I finish. So this is the compressed SIDS was a document in Spring. And the Spring document talked about two different flavors of how the IPv6 addresses have multiple SIDS compressed into them. And one of those flavors decided like it would be like multiple SIDS would be compressed into one v6 address, which meant that something the 6-man specified, which is the SRH, it talked about the address being directly copied from the SRH into the IPv6 destination address. And this is no longer true as of the CSID document. And the IESG thankfully caught it during the IESG eval. And there was some text added into the document which said like, hey, like the replace CSID doesn't do this as specified in 8754. So this document talks about changing some text in 8754, which says like the segment specifically is copied directly from the segment list into the destination address, and it says some processing is done on it. And right now, the only thing that we know of is replace CSID, which is one of the flavors of compressed, and that's exactly what this document talks about. So what we are saying is like the SID list doesn't always contain IPv6 addresses. This is kind of always something we had known and also documented in the I think it's 9800. But what we are saying now is that the destination address is derived by applying a function. And in this replace CSID case, it's like an expansion function to put the stuff in there. And the goal of this is not to change the SRv6 architecture, which is like the 8754 stays as is. And there's no changes to what goes into SRH as well right now. But what it says is like, hey, this is actually, we are noting this exception. And if somebody has other use cases to come after, they don't have to, again, go through this process of changing 8754 again. So it's a fairly new document, and there's like very little changes to the text in here. And we're talking about this because 8754 came out of 6-man, not out of Spring. And pretty much like we got positive feedback on this. If you have any comments or questions, please send us a note. We can discuss it. And we also talked about it on the Spring list. And again, nobody screened, but it's totally possible that we might hear screens later. But please do come and talk to us, like me or Adrian, or put it on the list, and we'd love to have a chat with you. Thank you.
Cool. I do not think anyone is in the queue, but just curious, how many people read the draft? Well, I suggest if you care about SRv6 at least a bit, please read the draft, provide your comment, and yeah, we'll move forward. Cool. Thank you very much. So the next is virtual ID. Yeah. Stop slides. Okay, yeah, I'm getting your slides up. Here is a clicker. Oh, sorry, wrong one.
Okay. Morning, everyone. This is Jaedong from Huawei. I'm going to present this update on this NRP network resource information in IPv6 extension header draft on behalf of my co-authors. First, a little bit about the background. The network resource partition, or NRP, is a subset of the network resources allocated on a set of links in the underlying network. And this concept is introduced in the RFC 9543 for an underlying network resource construct. The NRP can be used to support one or a group of network slicing services or enhanced VPN services as described in the RFC 9732. In this document, we introduce a new hop-by-hop option to carry this network resource-related information in IPv6 packets. It can be used by the transit nodes to determine the NRP the packet belongs to, so that the NRP-specific packet processing and forwarding can be performed on each hop along the path. This option can also be generalized for other network resource-related semantics and functions in the future. So it's a kind of a generic option, but currently we have the the use cases for the NRP. So in this latest revision, the changes is mainly to align with the terminology and the design principles concluded on NRP by the TIS working group. Here are the conclusions in TIS working group on the NRP data plane. Basically, there are three topics being discussed and concluded in the working group. The first one is the terminology. What do we call this NRP dedicated ID field? The decision is to call it the NRP selector ID. And the second one is about the length of this dedicated ID field. And the conclusion is the length of the ID, NRP selector ID, can be different for different data plane types. So it is the actual data plane encoding outside the scope of the TIS working group. The third one is about the strict match indicator. After some discussion, the working group considered that the encoding of this strict match indicator in the packet provide more granular control to the NRP-based forwarding and can be a nice to have feature. I also give the link to the mail which gave all these conclusions in the TIS. So here are the changes since the last presentation in 6-man working group. We made several revisions, but basically the changes are not very big. The major changes are the terminology alignment. According to the conclusions in the TIS working group, now we call the NRP identifier in the data plane as NRP selector. And when the dedicated ID is used for the NRP selector, it is called NRP selector ID. In the draft, there are also editorial changes, such as the updates of the references. Some of them has been published as RFCs. So here, for this meeting, we mainly want to have some discussion on the remaining comment, which is the length of the NRP selector ID in IPv6. We see that the conclusion TIS is that the length can be different for different data plane, and it's up to the working group of the data plane protocol to make the decision. In the current draft, we allow the variable length of the NRP selector ID. This is really flexible, but it may not be optimal for some hardware implementations. Actually, in the earlier version, we have the ID defined as a 32-bit field. This provides a reasonable large space to accommodate both the current and the future scenarios for the NRP usage. Well, we also received some comments that maybe some people want to make the length shorter. The purpose to make the encoding in IPv6 more compact. And also another consideration is to whether we need to make this length consistent between different data protocols like IPv6 and MPLS. So here we would like to check with the working group whether we can reach some consensus on this ID length, whether we would prefer to make it keep it a variable or we make it a fixed length. If we make it a fixed length, do we keep it as 32-bit or we want the other length? Also, another option is, do we want to support multiple lengths for this NRP selector ID? Because as just discussed in the MPLS session, there's a proposal to have multiple lengths for this field. We don't know whether IPv6 also wants this, do it this way. Yeah. So for the next step is after we reach consensus on this comment or the question, we will update the draft accordingly. Then we can request for the working group last call because it's been quite a while in the working group. Okay, thank you.
Suresh, you're in the queue.
Thanks, Bob. Thank you, G. So I'm probably one of those also people like who doesn't want a variable length ID here. So I would like a fixed length thing. Like for something that you want to use this for, like something doing a slice in a data plane, like please don't make it a variable length ID. It makes it very inefficient. And the second concern I had was this context thing. Do we know of like more than one use of this? Like other, so why, so if I back up my question, like why do we need a context and like a separate INR registry with possible new types? If this is the only use we know of, I would say like, let's do a one-off on this. fixed length ID, and directly correlated to the TS use case would be my recommendation. So, okay,
Yeah,
thank you.
thank you for your comments. I think the contexting was introduced based on comments and suggestions from our area director, which is to the concern is mainly about the limited type number for the options. If we consume one option type, it will be better to make it useful for multiple cases, and this can be. For now, we have the cases for the NRP, but it can be extended in the future for other use cases, but keep this option type, keep using the same option type with different context. That is some consideration about the.
That's totally fine, right? Like, but I have a hard time imagining some of the use case for this, right? So there was something that I wrote like probably like 10 years ago saying like, hey, we should start subtyping the options, right, in general. So that would be like a more generic thing. But here you have a specific set of semantics for slicing. So I'm just thinking like, yes, I totally agree with Eric that the space is running out, but if you cannot explain, at least like theoretically, what is a new kind of slice that's going to come out, because that's the only thing this can be used for. So I would rather have a option which has subtypes, right? Like generic extendable hop by hop option would be a better candidate for having that subtype in there, right? But for this specific one, I do have concerns like, that it has a context for additional things. And partially some of the stuff is that the variable length also doesn't help in the fuzziness around context, right? So I would say like first make it fixed length, and we can kind of talk about the context extensions later. Yeah.
Okay, we'll consider that. Actually, in the draft, we have some text about the generalization considerations on this option. Maybe you can also take a look and give us some feedback. Thank you.
Hi, G. Thanks.
Yeah.
This is Zafar Ali from Cisco, and we've been talking quite a bit on this topic. So,
Yes.
So the comments that were given earlier are in line with what kind of Suresh is also saying. The first question is this 32-bit length. This is billions. And this is a data plane instance of something. I do operation based on when the packet comes in based on this ID. It's a data plane. It's an extended DSCP, if you will. So why do we need such a large ID? That is making the encoding complex. Okay, it's to be burned in hardware. So that's a concern that was discussed with you offline as well. And then people may find abuse of this number. They may hijack this number to put something else that you don't want to be visible in the network. Who knows? I mean, but this NRP is something that from data plane, you have a specific DSCP style treatment. And on the management plane, you have kind of an instance in the management plane too. So for all the operators that, and many are here as well, that we have spoken with is in tens, maybe under 10, but nowhere billions or millions. It's completely unmanageable. That's one part. You mentioned that different data plane can have different ID sizes and all. That is correct. I would say maybe encoding, because encoding could be very much data plane specific. But when it comes to, the problem is that when it comes to interworking, these different sizes will then harm as well there. And in MPLS, we have 4 different sizes to be implemented in hardware. And then same discussion happened in parallel in MPLS working group. So I think we need to discuss that. I don't think we need 32-bit ID. It's too large. We can make it compact. We have shared with you a proposal offline, and we can make it generic for hop-by-hop header extension in future, like Suresh mentioned.
So your feedback is you think 32 is too large, but you want prefer a fixed length, and you prefer to make it a generic option, right?
Yes, fixed length, shorter and compact, so that it can be implemented in hardware with efficiency. We can discuss
I
more
got
offline.
a point.
There is a proposal that was shared with you. So
yeah, I know that. Just we are thinking whether if we choose one fixed length, we need to consider the current use cases, but also make it future-proof. 32 can support small and also large instance numbers. Right?
There is no future. This is in hardware. Hardware look at the packet, look at the number, determine how do I size queue. You think that we will have billions of queues in future in hardware? No.
We're not to state this to hardware, I think.
Sorry, may I interrupt? Just for the sake of time, it's very useful discussion and productive, but I suggest we take it to the list because
Okay.
otherwise we're going to run out of time.
Okay.
I'm sorry.
Okay.
Yes, sir.
Thank you.
Thank you.
冲锋线 of China Telecom. For the length of the ID, I think that the current 32 bits is suitable. It makes sense because we should have a perspective long term. Once the ID is too short, it will be very difficult to extend the length. So I hope that it should be 32 bits. That's my point.
Okay. Thank you.
Okay, thank you. Okay. Next. Okay, and next we're talking about young model.
Yes.
Right, yeah. So, yeah, I'm putting up slides here. Hold on. Okay, Fang, do you want to me to move the slides, so you're going to take control?
Yeah. Can I get the control of it? Oh, okay. Hello everyone, this is Fan Zhong from China Telecom. I'm presenting the update of Young Data Model for IPv6 neighbor discovery on behalf of the other authors. And you may have known this one since I have been presented it on Tuesday at V6 Ops. But I'm still going through this one here. I clicked on the next page, but it seems that nothing happened. Okay. This draft is about the young model of an additional configuration and management of IPv6 neighbor discovery and related functions that are not included by the existing IETF young model, such as IETF IP or IETF router advertisement. And the IPv6 ND young model covers the functions like the IPv6 address resolution, proxy neighbor advertisement, neighbor unreachable detection, duplicate address detection, and enhanced DAD, and the related statistics. Here's the change since last time. This one, you may have known that this one was originally an RTGWG workgroup document corresponding with another RPyoung model draft. But during the RTGWG session in Madrid, there was a discussion suggesting that Sixman might be a more suitable place for the IPv6 neighbor discovery young model, and it concluded with moving the draft here and got readopted. Based on the comments from the last session and mailing list, we have changed model name to IETF IPv6 ND and added notes about enhanced DAD and removed notes related to send and send proxy, as it has been removed from the latest version of IPv6 node requirement due to their lack of deployment. We also added Appendix B to summarize the existing nodes related to IPv6 ND, which are separated in different models from different RFCs. And for now, the router configuration variable described in RFC 4861 and node configuration variables in 4862 have been basically covered. And others are function enablers for address auto configuration extension in 4941 and enhanced DAD in 17527. And that's all of it. Any comments?
Okay, Jelinkov, I put myself in the queue with Kat's chair on actually. So I hope that people in this room do operate IPv6 networks, and I guess many of us use young model for something. So please read the draft. If you think it's perfect and it contains everything you need, say so. If you think anything missing, please say so. Because I think the draft actually requires some input from operators or people who use it, right, to see what actually is missing, what you'd like to be there, what. Because yeah, I personally provided some input there, so I hope people could read it. And again, don't hesitate to say, I think it's good, right? So we know that you read it and you're satisfied. Thank you. Okay, thank you.
Okay,
Fun.
thank you.
Okay. Okay, I'm gonna give you clicker. Yeah, floor is yours.
Hello, everybody. I'm Xiaoming from ZTE. This presentation is on IPv6 query for enabled in-situ OEM capabilities. This is the recap of this draft. This draft defines ICMPv6 extensions to achieve IOM capabilities discovery in IPv6 networks. This draft is a companion document of RFC 9359 developed in IPPM working group. This draft uses RFC 4620 IPv6 node information queries as a foundation for extension. In this draft, for the node IOM information query mechanism, there are 5 IOM capabilities objects are defined. This is the format of IPv6 node IOM request message. In this draft, for IPv6 node IOM request, it defines new queue type. This new queue type indicates the NI query is a node IOM capabilities query. And this draft also defines new code to indicate the data field contains a list of IOM namespace IDs. For the new data in this message, it's a list of IOM namespace IDs. This is the format of the IPv6 node IOM reply message. For this message, this draft defines new queue type, and that new queue type is copied from the IPv6 node IOM request message. This draft also defines new codes. Code 1, it means no matched namespace ID. Code 2 means it exceeds the minimum IPv6 MTU. This draft also defines new data for this message. It's a list of IOM capabilities objects. This is an example of the IPv6 node IOM request message and the reply message. On the left side, it's the IPv6 node IOM request message. In this message, it contains 2 namespace ID called namespace ID 1 and namespace ID 2. On the right side, it's the example of the IPv6 node IOM reply message. In this message, it contains several IOM capabilities objects that's defined in this draft. 2 objects are for namespace ID 1. Another 2 objects are for namespace ID 2. Yeah, next step. This draft has been adopted since December 2022, and it has already been reviewed and revised for several rounds. The authors think it's already stable So we'd like to request for working group last call of this draft. Thank you.
Comments, please?
Okay, so how many people read the draft or at least recent revisions? Maybe not the last one. Okay, so we clearly need more people to read it, write, and comment. So let's see. I'll ask people who are aware of the problem statement and the area. Yeah, please review, provide the comments, and we see, because yeah, we need the group to decide if it's ready to be advanced or not. Yeah. Okay. Thank you.
Okay, thank you.
Okay, Tim, you are next. I am getting slides. Hold on. Oh, not the requirements. Okay, slide clicker. Yes. Just a second. Now. Yeah.
Okay, hi everybody. I'm here to talk about IPv6 node requirements. So this is the third version of this document. We got the band back together, so this is the same authors as we did 8504. So Tim and John are my co-authors. Things we've done since IETF 123. Some of these comments directly came from 123. Hop by hop processing is a must in the document now. We added a must for 8028 and less constrained. Somebody asked me about this. Constrained is defined in that document. So if you're curious what that is, we actually have a definition. So that's what we said, which I think is good. So when I wrote down this, these were all things we added that were must, things shoulds, may, and informational things that we put in the document. So the should side, we put PD, DHCP, v6, 9663 to allocate prefixes to host. We put that as a should. Discovery of v6 prefixes for address synthesis. We put that in there as a should. And PCP, we've talked about that, I think the last two IETF meetings, we added that finally as a should. The next one, I've already gotten 2 comments that this should be a should, but it's a may now. So actually, if people want to comment on this now, that'd be great. We're talking about DHCP v4 option 108. So in the document now, it's a may. This is, for those who don't remember, this is allowing a host on the v4 side to say that, hey, I'm fine not getting v6. I mean, not getting v4, sorry, check that. I'm fine not getting a v4 address. I support v6 only. It's a may now. I don't have super strong feelings. We'll probably move it to a should based on the 2 comments we've gotten. Run to the mic now if you really hate that idea. Oh, here comes Lorenzo.
Yeah, I think.
Hey, buddy.
I actually had a question about 7050.
Yeah.
You mean should not, right?
No, it should.
Should? Like, don't we have another document in v6 ops that says don't do it?
May I jump the queue here, right? V6 ops document differentiate, at least currently, cases of mobile versus non-mobile hosts. So if we include mobile devices here, I think it might be a bit early to say should not, because it would break mobile devices. However, I think we also should say that it should use prefix for discovery from array, because V6 ops recommends it to use first. So I think we don't want to have conflict between different documents here, right?
Sure, agreed. I think we just want to follow what the group consensus is. So yeah, we'll take another look at the v6 ops docs.
Right. So I guess the pref 6.4 option is already there.
Yes.
Okay.
Yes.
I mean, that definitely should be a
Yes.
should, right? At least.
Yes. I'm going from memory here. I'm sure someone's going to tell me something different here in a minute, but I think it's in there. Okay, informational. We added some stuff about, hey, if you're curious about extension headers in your network, you should use 9740 to get better visibility of what's going on. And then we added some additional text for v4 mapped DNS entries and the joy that those bring. Okay, so that's what's in the document now. Okay, and we've arrived. So the deal here is a little bit of history. I'm going to go back. It's not in this slide, but in 8504, we specifically added text for extension header limits. And the reason we did this is because there was nothing else documented, and the working group at the time felt like we should put some words around extension headers and what is expected to be supported in general node devices. So what's got us in a little bit of trouble here, insert the conversation from earlier this morning, is there's text in there that at the time, I think we all thought we could remove when we read this document again because there'll be a better document that exists. Well, unfortunately, here we are, and there is no better document that exists. So 8504 seems to be referenced for how to deal with extension header limits, which I do not think is a good thing. I don't think this document should be where this text lives. It should live somewhere else. It should live in a document that talks about all the extension headers stuff. So we're in a little bit of a bind in that we either have to remove the text. Currently, this version now points to the since removed version of EH limits. So that's definitely not going to be an option. So we either have to remove the text, leave the text where it was like 8504. What do people want to do? I enjoy awkward silences as much as anyone.
Okay, I was actually in the queue for another reason, but I will comment on this, right? I agree the text should not belong here. And I think, yeah, for the sake of progressing this document, right? I think it might make sense to avoid this topic. And if, again, if the group has an interest on working on specifying anything about extension headers, we can do it separately, right? I'm not sure we can constrain the node right now, but yeah, I think it's fine not to have, personally, no heads on, right? I think it's fine to remove the text.
So that's a vote for removing the text that was inserted in 8504 and basically revert back to the text from the previous version, which I'm blanking on the name. It'll come to me. Okay. Anyone else have opinions? Okay. Yeah, I mean, we'll talk about this as authors. Obviously, if six-man, go ahead.
Nick, you're in the queue. Do you have a comment on this? No. Okay.
Wise, my friend.
Now out of the queue.
Okay, so in general, I think, it makes the most sense. Like I said, I haven't totally consulted with both of my co-authors, but my instinct here is to remove this text because I don't think it's accurate anymore based on the conversation that's been going on list. I think that is the easiest thing to move this document forward, and then the working group can figure out what it wants to do with extension header limits. I don't think 8504 should be the place where we all point to for this. Okay, that's good feedback. Thank you, everybody. Okay, there's a couple of documents that we're sort of stuck on, and I don't mean stuck in a bad way, that they have to finish up their process before we can push forward with them. We'll make some updates. Default address selection, 6724, I believe that's in the editor's queue somewhere. So that one needs to wrap up, and we'll point to that. One thing that Tim, the other Tim, the better Tim, noted was that we need to update the text to say we must do Rule 55 and that it matches 6724. DHCPv6, this it was going to internet standard, so we should just update. There's no text change as much as this is a reference change. And the same thing is true of CE router, which I forgot was in here, and I should know that. I forgot, so we'll do the same thing for that. That is in that document. V6 Ops looks like it'll finish that document before this document finishes. So those are the three I'll say that are just general. We're going to scoop up. We've had references to them before. We're just going to pick up the latest ones. I don't think this is controversial. At least I hope it's not. All right, this is the section. I think Lorenzo is going to get up and say something to me about address synthesis, and I'm going to get confused again. But these are the documents we wanted to talk about that should we include, what do we want to include. So I have the ones that we flagged so far: discovery, address synthesis, router alert option, deprecation. This is a weird one because it's telling new processing people not to do it, but I don't know if we want to reference it as informational would be the option here. And the other ones we have is mostly V6, AAA filtering, and DHCP v4 over DHEB v6 RA. All right, Jen, go ahead.
Yeah, I, as a author of two documents mentioned here, right? They are from V6 SOPs. The informational are more about how you deploy the thing. So I'm not sure you can say much in your document. For prefix, so prefix discovery. Actually, I was on the queue initially for this. I looked in the document and I'm very much confused by your previous slide about prefix discovery, because section 10.1.2 already saying that it's recommended that you using prefix 4, you may do 7050. So you're kind of already saying what 9872 says, and it's kind of not what your previous slide was saying about should do 7050.
Are you sure it's not a should?
Maybe it should somewhere else, but I think
it's a should somewhere else.
Oh, so you
for both of
so
us.
you say in one place you say may, in another place you say should, so it's even more interesting.
It's possible I screwed this up and it might be in the may section, so I'll take that one.
Yeah.
That is possible. So if that's what it says, then that sounds right.
Okay, I
But
just
I'll sync those up with whatever V6 op says now.
okay, cool, thank you.
Yeah, for sure. For the other two, traditionally what we've done for V6 informational drafts is we do this for like CRAD or other ones. We say, hey, if you're in this section reading about this as an implementer and you want to know how to deploy this, go read. We use it as sort of a pointer. Obviously it's informational and we're not making any claims. I'm sort of giving people a direction. Hey, Lorenzo.
I just want to say in another potential document to consider, I don't think you had it earlier, is the DHP adder reg.
Oh yeah.
That could just be because I think the last time we did it, we discussed it wasn't on RFC yet. Now it is. I don't know if we want to say anything more than may, but I don't know.
I think we should probably tell people it exists. Yeah. It's a good thought. Thanks.
Developer, the RA on the bottommost draft mentioned here is relay agent and not router advertisement, and the draft is entirely inapplicable to this, I think.
So Tim's gonna have to, if he's online, he's gonna have to remind me. He flagged this one, and I can't remember what he said about it. So I'll check on lists. Yes, it's obviously I said RA, but it's really about relay agents. I know that. As the GHCP chair, I think the deal here is just, again, this is referencing how you might do this. I'll have to go back and look.
I don't see how it fits in here.
Yeah, I didn't flag this one, so I need more detail. Thanks. It's a good point.
Tim, I put myself in the queue. I'm just trying to remember, have we discussed idea of PFLAG support as a node requirement?
What support? Sorry.
So for PD per host.
Yeah.
Yeah, because I do not see reference in the doc for it.
I think we added 9663. Are we looking at the latest one?
Because the 6-man RFC, right, which specifies the PFLAG behavior, it's 9762.
Yeah, we do not have the PFLAG. No, we don't have that. You can add that.
Yeah, I'm obviously biased, but I'm just asking if it was intentional decision which I missed. Or
no, I don't think there's anything intentional about that. At least I have no recollection of that being intentional. So I'll add an issue for that. So the PFLAG should be there as well. I agree.
Yeah, and I guess it was just probably published after we met last time. So I guess maybe.
Yeah, I'm assuming it sounds like there's a couple we missed from maybe they're in the editor's queue. I thought we got them all, but the PFLAG I've heard, and I have to sync up the headers. Okay, those are all good. We have a couple of open issues left. Some of them are minor. Some of them are more meta. One of them's about do we need an energy efficient section? And do we want to update the API text? Those are probably two of the more super high level ones that nobody has taken on because they're kind of nebulous. So we'll have to look at those too and see. I don't think there's been any major API changes, but we do have a section, and so we should just take a look at it to make sure the world hasn't shifted from underneath us on those. The issue tracker links there. Feel free to send email or links. We'll pick them up. Okay, I think I'm done.
So what's your take on when you think this will be ready?
I think we're getting closer. I think if we remove the extension header text, that was one of my questions today, if we were going to wait for that or not. It sounds like the general consensus is to wipe that text out, which I think speeds this up. So I would think we'll be close, maybe about ready for working group last call at the next IETF, maybe before then, if we can get everything in.
Okay,
Thanks.
thank you.
Okay. I believe David. Okay.
Okay, good morning, everyone.
Hold on. Should work now.
Does it? It does. Perfect. This is a multicast address format for IPv6 that is less than the link scope. So let's start. What the fuck is this? Some layer 2 technologies have multicast capabilities that reach a specified scope that is not the entire link. I would like to be able to access that from IPv6. So this is a new just address format representation, I guess. I picked just randomly more or less FF22. That's currently unspecified or rather reserved. The combination P1, T0 is just forbidden by the current address architecture. This introduces a new identifier which lower layer technology this refers to. Right now there's only Ethernet there. And that allows having a different mapping rule from the v6 address to whatever address the lower layer uses. Here's a visual representation of the entire thing. If you're a visual person, take a few seconds to look at it, but it's really just a different prefix, basically for v6 multicast addresses, that is then followed by link layer technology identifier, and then whatever you need for that link layer. And for the case of Ethernet, there is this reserved group range 180C2, and then we need 3 bytes, and those 3 bytes are in the v6 multicast address. That's all this is. Yep. Sorry. Right. This works like all the other scopes, basically, except we can't put it between 1 and 2 because there's nothing left between 1 and 2. The variable scope allocations that are in the IANA list probably apply. It doesn't make too much sense for most of them, but I don't see why this would be special cased. They also apply for interface local, where they also don't make a lot of sense. So just for consistency, anything that is on the variable scope allocation list would just apply to this one-to-one. And yeah, I'm expecting a whole bunch of why questions on this. This is specifically the goal here. There are 3 special group ranges in Ethernet. They listed here. The 0E1 is most well known because it's used for LLDP. In IEEE 802.1q, these groups are defined with their respective scope. I do want to emphasize here that they are not allocated to specific protocols there. So they are defined as a scope, and this is exposing a scope. So this is not treading on some protocol address specifically. Some of the other addresses in these ranges are assigned to specific protocols. Technically, they are exposed here. Maybe don't use them. The logic here is just it's a consistency. Again, even more on the why. There are multiple drafts that are suggesting the use of LLDP for what I consider layer 3 functions, or what I think everyone should consider layer 3 functions. LLDP itself is just a simple advertisement protocol. It's a bunch of TLVs you stick in there, and it has a lifetime. That's it, more or less. So that part is not special. The part that is special about LLDP is that you can use these special scopes in there. You can actually, the specification suggests that you can reconfigure LLDP to use a different one of these special groups, although by default it's always going to be the 0E1. But still, you have the capability there to use a protocol that will never cross any layer 2 device, i.e. it will only go to your immediate switch or whatever. And that apparently is useful for some use cases, as the existence of these drafts shows. So I would like to have the capability to do this with IPv6 rather than with a layer 2 protocol, because they carry layer 3 information. This is useful in a whole bunch of cases. The most popular one seems to be any case of EVPN, where the first switch in front of you is the VTAP, which in terms of IEEE 802 is a bridge, and it should not forward these groups. So you can do an advertisement that will not cross into your VXLAN, whatever EVPN domain, and need to be replicated there. And that seems to also be the motivation for some of the drafts mentioned before. It can be useful as a security characteristic because it's guaranteed not to be forwarded. It's similar to VLANs in that you have just a separate area of propagation. You can use this to get visibility in the layer 2 hops from layer 3. So I know for debugging a whole bunch of people, you just ping FF02::1. You just see all the hosts on the network. Now you can do the same thing with a limited scope address and see all the hosts until the next switch, which is hopefully only one host. Or with one of the slightly larger scopes, you can see all the devices. I do think it's very important that this also enables fate sharing for the drafts mentioned before. You're not using a layer 2 protocol to carry layer 3 information, you're using layer 3 itself. So if IPv6 is broken, that also breaks the advertisements, which is desirable. And last but not least, you can't really firewall LDP, you can firewall IPv6, so it would make these advertisement protocols firewallable, basically. Right. That's it. Questions?
Michael Richardson, I read your document. I don't know when it came out, a couple weeks or months ago. Great, thank you. I'm very supportive. The other thing that's useful is RFC 8994, which is GRASP, used in Anima for discovery. And we would really like to be able to discover the devices on the local layer 2, not crossing the whole WAN EVPN thingy, because we would like to make an adjacency with that device and not with all of the things that are out there. In fact, we have a problem. We would like to not, if there's too many of them, it's just it's a silly thing. We want to see the real topology. And so this is exactly what we would want to do for our GRASP discoveries. And it's unfortunate we didn't think about this 5 years ago. So please adopt. I'd like to do this.
Thank you.
Stig Van Haas. Yeah, I like the idea. I think this is useful. And yeah, I might reach out to you later, but I think it's pretty well defined. I think it can work with the other IANA, variable scope assignments and so on. I wonder if this could be used for IGMP, for MLD snooping, perhaps. I'm not sure, but
maybe. I mean, the problem is there isn't currently a group in Ethernet that corresponds to MLD snooping, because that's not necessarily a function that's enabled on all the switches.
Right. Yeah. So what I'm thinking is, normally you want each switch to do a query and get reports just from the directly connected. Hosts, right? And you do lots of tricks to filter out.
I mean,
but anyway, we can think about that. But yeah, it's a great idea.
Eric Klein, No Hats. I think this is very interesting. Yeah, I think it's worth pursuing discussion. A quick question on why the multi-scope and not just link local?
You mean the 3 groups, or what do you mean with multi-scope?
Sorry, why not just use? Why isn't it just link local scope? Link scope?
You mean the entire link, like the existing scope number 2?
Or correct, because if I understand correctly, then from the sender's perspective, it has no idea how large the link is. So it could be sending to everything on the link, or only the first hop. It has no idea.
The problem I'm trying to address is that there's no way to request the different scope from the upper layer, basically. So in theory, if I do a packet socket, I couldn't just send an IPv6 packet with a different destination multicast MAC address. That would work. But that means I need to bypass the IPv6 stack, because the IPv6 stack doesn't have this mapping for a group address to this Ethernet MAC, So yeah, I would rather have an explicit way to request these groups by a well-known mapping from a group address. That's the idea here.
Yeah, I guess I need to read. It still seems to me like the scope is linked, but like you could move the bits high, and there could be multiple multicast addresses below.
I mean, yeah,
Because
it could be somewhere else.
Otherwise, you only have
Yeah.
port UDP port differentiation to target different applications.
Okay.
Right. So anyway, I'll take it to the list. Thank you.
Okay, General Go with chair's hats on. I do not see a way to do three-way room poll in Miteco. However, anyway, we're supposed to do that kind of things on the list. And I think what you're asking for is actually adoption call. Because those questions normally are discussed. No,
So
you don't want adoption call?
Well, I do think I need to do a bit more editing. So there are some copy-paste mistakes that have been pointed out in the draft. That's why I wasn't going for adoption. But yeah, technically, I'm asking for adoption.
Let me answer. When we do adoption call, it does not mean we're not asking if the document is perfect. We're asking
yeah.
if it's a good idea or is it a problem to solve. And obviously, people who say yes for adoption might actually disagree with the content of the document. So if you'd like us to wait for you to publish an updated doc to fix typos so people do not pick up on them, that's a different story. But it looks like we should do an adoption call,
Yeah,
right?
okay, let's just make this an adoption call, I guess, and we'll go from there.
Okay, thank you. Aaron. Yeah, I am getting your slides. Compact, header, slide clicker. Yes.
Hello, Ron Bonica from HPE, presenting work from myself and my co-authors, Jing Li and Siboa. I'm going to say something shocking, so everybody look up from your email so you won't miss it. Next slide.
No, you have clicker.
Oh.
Well, if you want.
The shocking part hasn't come yet. I'm going to describe an IPv6 experiment that we'd like to do. And it introduces a new IPv6 destination option called the CRH helper. As you could guess from its name, it's used with the compact routing header. It's a routing header. It has a list of SIDs in it. The SIDs identify the next node to be visited along the path. It appears in the destination options header that precedes the routing header. This is the shocking part. As far as I know, no one has ever used that capability before. There's not a single routing header that relies on a destination header before it. It contains the information required to convert a SID in the CRH, a CRH SID, to an IPv6 address. So what's different? In the CRH, we go to the CRH fib to convert the SID to an address. Now the information we need to do that conversion is in the packet, not in the fib. So you don't need that CRH fib anymore. You don't need any routing protocols to maintain the CRH fib. This is very useful in underlay networks where every single interface is numbered from a single /112 or a single /96. What you do is you put the prefix in the destination option and you put the last few bits of the address in the SID. That's what the SID is in the CRH. Functionally, this is identical to the deprecated RH0. The only difference is it's much shorter. In many use cases, you save an awful lot of overhead. So how does it work? The CRH contains a set of CRH, the CRH helper option contains CRH helpers. Each helper specifies the prefix for a range of SIDs in the CRH. So let's say you have 10 SIDs in the CRH, one helper might be the prefix for the first 5, the next is the prefix for the next 5. Typically, in the applications where this will be used, all of the SIDs have the same prefix. So there's only one helper in the option. When a node processes a SID within the range, it forms the IPv6 address by concatenating the helper prefix with the CRH SID. Now, there are some security considerations that you're probably all thinking about. Well, didn't we deprecate the RH0 for a reason? Maybe that was premature. It turns out, in the years since the RH0 was deprecated, we've generated very many routing options. And for almost all of them, we've said that it's okay to use this so long as it's done in a limited domain. And we rely on ACLs to maintain the limited domain. This is yet another use case of this. So I'd like you all to read the draft. And to get you all to read the draft, I'd like to request a call for adoption.
Okay, thank you, Ron. I did look in the draft. I have to confess it was not proper like reading, but I do like that it's an experiment. And actually the draft already defines criteria for like results of the experiment, which I think is great.
Yes, I think,
yeah.
I think all experimental
Yeah.
RFC should include
Yeah.
criteria for success.
Yes. Okay. So we know what we're trying to achieve. It looks like there is no IANA requirements in this case. You're just reusing.
Right. We're using
Using
experimental
the-
RFC experimental code points.
Yeah. So it looks like reasonably lightweight experiment. So yeah. Okay. So how many people read the draft? Oh, cool. So okay. So the chair is discuss here, and we'll please read it. Please say what you think, right? Because you will have to do it anyway during the adoption call.
Okay. Thank you.
Okay, thank you. Okay. Yes, so slides. So next, what is next? Oh, now we're going to talk about DNS 6.4 functionality.
Hi everybody, this is Chen Hao from China Telecom. On behalf of all authors, I will present this topic, updates to DNS 6.4 functionality, advertisement for DNS RA option. Next slide, please.
You want me to move the slides? Okay, let me take
Yes,
the slide
thank you.
control. Okay, yes.
Oh. Use case. When we deploy the IPv6 only in network, there are actually two environments. We want to make sure that the IPv6 only user can get a DNS 6.4 server address, and while the dual stack users can get dual stack environment configuration. But we've found that the DNSR option cannot tell host whether it supports DNS 6.4 functionality. Next slide. Okay, can control. So we want to introduce a T flag bit allocated in the leftmost bit of the reservoir field to signal the presence of DNS 6.4 server addresses in the option payload. That's the photograph. And next slide. So we just want more comments and contribution from the work group. And we actually have some feedback from V6 ops. We think we should need more comments, and we don't adopt it as a working group draft.
Okay, we have people in the queue. I can.
Philip Teasel, I totally understand the reason why someone wants to separate DNS 6.4 capable resolvers from not DNS 6.4 capable resolvers. But now comes the big but. We have the experience that changing RA options usually for deployment case takes at least 4 to 5 years to be usable in any way. And so my feeling is if you really have the use case that you want to determine whether a DNS resolver is v6 capable or not, the chance is much higher that you just take the resolver, test whether it's DNS 6.4 capable by simply doing a DNS lookup, and then either filter it or filter the DNS 6.4 address space from the DNS results. So I think the chance, as you have to touch the UE anyway to make this thing useful, is fixing the way DNS 6.4 is handled in the UE instead of introducing a new option to an array option and having to touch the UAE to support that one.
Ted?
Okay, thanks.
Yeah. So the question I had about this when I read the draft was like, why? And when I say that, I don't mean that there isn't a use case for this, because obviously there is, but the problem is you have to, I think, correct me if I'm wrong, you have to make a change both on the router and on the host in order for this to work. And if you're going to make a change on the host, we already know that it's kind of operationally, or at least, conceptually better to do address synthesis on the host rather than using a DNS64 server. And indeed, there's plenty of people who would argue that DNS64 should just be never used. So the question is, given that that's kind of feels like it's the direction that the IETF is going, this feels like it's moving in the opposite direction. And why not just use the Pref64 option or the IPv4 only.ARPA RFC 7050 solution and not do this?
Lorenzo, go for it.
Yeah, I also don't see the use case at all, to be honest. In particular, what looks like, that it looks like the new option would be parsed by existing hosts as well, because it's like actually the same option. It's just a new bit in the option. And so it just like doesn't seem to do anything useful that I can see. I mean, yes, it tells new hosts that some servers are different, but those hosts already have the Pref64 option, so they can already do synthesis themselves. This is implemented in major operating systems already, so that's already a solved problem. So I really struggle to see what the use case even is, actually.
Yeah, okay. Jen Linkova, no hats on. I actually, thank you, Ted and Lorenzo. Basically, you're saying what I was going to say. It looks like this draft kind of is not clear on what use case is and why it could not be achieved by using local synthesis and Pref64 on device and just either eliminating 7050 whatsoever or providing the same server to the clients. So I would suggest to authors to at least make it more clear, because it looks like a lot of people who read the draft are a bit confused. So just for sake of time, we're going to move to the next presentation, but thank you the authors for presenting it. But I think it would need more work, because it definitely there is a feedback, but feedback is about people not fully understand the problem statement. Thank you. And just a sec.
Okay, thank you.
Slides. Okay. Confirm.
My name is Zafar Ali. I am actually presenting on behalf of my co-author from HPE. And there are a couple of customers that have the deployment scenario that is addressed by this draft. And they are also my co-authors. And this is where deployment is happening. So problem scope. So it's very important to understand the scope here, because this is relation here. It's about handling time to exceed errors in SRv6 VPN core network when customer deploy uniform model. And these are the customers that are deploying uniform model, and which really means that they actually go explicitly on their ingress PE and configure something or through some policy, say that it's okay to propagate TTL or hop limit from incoming customer packet to the provider header. So outer IPv6 header. And CE in this case could be v4 or v6. So what we are doing is that so the scope is again the SRVC capable P node. So in this example, we take an example when hop limit or TTL was set to 2 from CE. And CE is sending a trace route packet to the far CE. So CE1 on the left, sending a trace route packet to CE2. So, and the TTL is 2. So when it comes to PE, PE has a configuration to propagate TTL to the or hop limit to the outer IPv6 header as it encapsulate that IPv6 header. So now the packet, which is the outer IPv6 header, has a TTL or actually hop limit of 1. And this goes further to, and the TTL expire on an SRVC capable P1 node, which is the provider node. And in here, the P1 node needs to send the ICMP error time exceeded back to the CE1. Just like what we do for MPLS, that in this case, because PE1 has the full context of what to send to CE1, P1 operates on its outer header to determine the VPN SID for the far PE, which is PE2, which is actually is an incoming packet. The VPN SID is an incoming packet. It uses that VPN SID to send the packet towards CE1. As when packet leaves P1, it goes in data plane to P2. So it's like looping back through the VPN SID. There's no change to P2. It just look and apply the VPN SID operation on P2 and loops it back towards PE1, and then PE1 decapsulate the ICMP packet and send it to CE1. So this is basically tunneling it through. And we have been doing this for MPLS for many years and is being deployed for MPLS. This way of doing the tunneling of ICMP error to CEs is being done in MPLS. So we are just using the same methodology for SRVC's capable node. So this draft was presented in last IETF. We had more time. There was a lot of discussion on the mailing list. A lot of good feedback was received. We addressed all the comments. There was a feedback that Spring should have a say whether Spring like to work on this problem statement. So we did present it in Spring in this IETF, and Spring chairs agreed that they would gauge the feedback, and there was a poll actually with lots of interest in this work for Spring. But I like chairs to say it rather than me saying it. So Spring chair that would be. And we would like to progress this document. We'd like to get adoption of this document and appreciate any feedback and cooperation. Ron.
Ron Bonica, HPE. You've scoped this to SRv6 tunnels. I believe that it works equally well on IPv6 over IPv6 tunnels, which means at very least the title is wrong. But I believe it works equally well in IPv4 over IPv4 tunnels, which might mean that it's in the wrong working group.
Yeah, so Ron, if you like to cooperate on generalization, that would be appreciated, and we can work offline on this. But here, I mean, for the tunneling technology like IPv4, IPv6, and for other IP tunneling technology, I am not a very expert, so I'll rely on you to give me text, and we can collaborate for sure. If that's the route we're going to go, and if the int area is the right place, we've been presenting to int area as well. Last IETF with this IETF too. So it's being discussed and as to chair where they would like it to work, and we're happy to work with you.
Sounds good.
Thank you.
So if the focus is SRv6, then we will need to hear from the SRv6 chairs that there's interest in this. But if the document evolves and is now more general internet area, then, well, then it should probably be brought to internet area. But we'll wait to see. We will look to talk to the Spring chairs, but the two of you should work on this and decide what you want to do. So thank you.
Sounds very good. Thank you so much.
Well, so I think we are done and we got all the talks in and have a minute left over. So we hope to see many of you in Shenzhen. I think I'm going to travel if I can. So hope to see you there and have a good rest of your IETF and safe trip home.
Disconnected from.
Sorry?
I disconnected from meter when I still presenting.
Well,
Whatever.
oh, right. It's still showing.
Yeah. But they're gonna close.